In biometrics, the crossover error rate is used to determine the accuracy of the biometric system. So we have a few different types of biometric errors. The true row denotes when the device is working properly. The false row denotes that the device is malfunctioning. So a true positive means that the device successfully authenticated an individual. A true negative means that the device successfully did not authenticate an unauthorized user. So the device denied access to an unauthorized user. It's working correctly. Then we go to the false row. A false positive means that somebody who was not intended to get access got access. Like a fingerprint scanner, and that person is nowhere on the system, but they just have to put their finger on the fingerprint scanner and the door opens. And a false negative is when an authorized user is denied access. So somebody who's supposed to have access cannot gain access through the biometric system. So the worst case scenario is a false positive, where unauthorized users are granted access. And systems with high error rates might falsely reject users or falsely approve unauthorized users. If you have high error rates, you're going to have more results from this false row. The false acceptance rate is the rate of false positives, where unauthorized users are granted access. That's the false acceptance rate. The false rejection rate is where we have false negatives, okay, where authorized users cannot gain access. They cannot be authenticated. So biometric devices usually can be adjusted to obtain the proper crossover error rate. Now, why is it called a crossover error rate? It's because it's the rate or the place, the point on the graph where the false acceptance rate meets the false rejection rate. That's the crossover error rate. On the y-axis we have the error percentage, and on the x-axis we have the sensitivity. So you can adjust these parameters to obtain the proper crossover error rate and the one that you desire. Most biometric devices, they're not flawless. You're going to have one error one way or the other, so you need to determine what you're more comfortable with. Higher sensitivity equates to better security, but more false negatives. Okay, more rejecting of authorized users. Fingerprint scanners work by examining a user's fingerprint. Now, users all have unique fingerprints, or nearly unique fingerprints. There have been some very rare circumstances where people have had indistinguishably identical fingerprints, but that's incredibly rare. So human fingerprints are very complex. There's a whole science behind it, and fingerprint scanners work by placing LED lights or scanning the fingerprint using LED lights, and then by illuminating the finger, it registers the shadows and the patterns produced by the fingerprint itself, and it takes an image of that. That's how an optical scanner works. There's two main types. The optical scanner will shine LEDs onto the fingerprint and then register the pattern, the light pattern that develops based on the shadows and made by the ridges within the fingerprint. A capacitance scanner works by using electrical pulses to create that same type of image. So instead of lights and imagery, it uses electrical pulses. So capacitance and optical scanners are the two main types. The retina is located towards the back of the eye, and the retina scanner maps the pattern of the blood vessels within the retina. Every person has like a unique pattern of these blood vessels, similar to fingerprints. It's completely unique. It's not dependent on genetics or anything. It's just each individual has a different way in which the eye forms these blood vessel patterns. So the scanner uses low energy infrared light to illuminate that retina and read that pattern. This is often confused with an iris scanner. Iris is the colored portion of the eye, and the iris scanner will read the pattern of that iris. Those patterns are unique between different humans. So the iris scanner will use a near-infrared illumination light to shine on the eye and then read that pattern and compare it to a pattern that it has already been inputted into the authentication system. Voice recognition uses a voice print, which measures the user's tone, the cadence, how they spread out their speech, the volume, whether they're an alto or a soprano. Those are all combined together to create a voice print, and that voice print can be used to authenticate users. Voice recognition requires machine training. It requires users usually to read a series of predetermined words or sentences so that the machine can learn their speech pattern and map out their voice print. Then once the user tries to authenticate, their voice is compared to the voice print on file to authenticate the user. Facial recognition identifies key features of the face, like the space between the eyes, jawline, nose, lips and mouth width. It uses video or digital images to do so. So it can be, in many instances, incorporated with the existing functionality on a device. Like mobile devices often have a self-facing camera. You can use that also for facial recognition. Facial recognition is notoriously unreliable, and it can definitely have high error rates, and I think it's the least reliable of all the biometric factors that we've talked about here. With biometric implementation, you can implement biometrics with any of the access control models we've talked about, and it can be used for physical security. It can be used to authenticate to a network for network security. For example, you can use facial recognition to unlock your mobile device. You can use a fingerprint scanner in conjunction with a door lock. You can use voice recognition to log on to a laptop using the laptop's microphone. So you can incorporate biometrics with multi-factor authentication as an authentication system on its own. It can be used with any of the other techniques we've talked about when it comes to authentication. So keep that in mind. If you want to use multi-factor authentication, you don't want to have everybody carrying around badges. You can just have your users remember a password and then maybe say a voice page for voice recognition, or use a laptop-based fingerprint scanner, or use a iris or retina scanner. So the implementation can be used with any of the techniques we've talked about already.